Hi everyone, welcome to LearnNCode. In the previous classes, we had a great discussion on types of operators in Python. In the first session, we have discussed about arithmetic operators. After that, we have seen some examples. Next, we have discussed relational operators, or we can say comparison operators. After that, we have discussed bitwise operators. Next, assignment operators. After that, logical operators. Finally, we have completed about the membership operators and identity operators. That means till now, just we have completed the theoretical part about all the operators in Python. Now, in today's session, we are going to have hands-on experience at Python shell on these operators, from arithmetic operators to last one, identity operators. Just fastly, we are going to discuss each and everything at Python shell. Let us see. Now let us discuss arithmetic operators at Python shell. Let us declare the variable a is equals to 2 and b is equals to 3. Here we are declaring the variables, at the same time we are initializing. A value is 2 and b value is 3. Next we are going to perform first addition, a plus b. How much? 5. Arithmetic operation, addition completed. Next a minus b, what is the value? -1, and you know the multiplication is a star b. 2 3 is 6, and next we are seeing the floor division. It is giving the integer part 2 by 3. 2 by 3 means 0.6 something, right? But it is not going to give the float value. It gives only the coefficient, means integer division. That's why the result is 0. If I use ordinary division a by b, we are going to get 0.6 something, right? 0.66. This is the difference between the integer division. This is known as integer division, and this is ordinary division. It gives the floating point value, right? It gives only the integer part. That means out of 0.66, the integer part is 0 here. So floor is giving the integer value here. This is also known as floor division. After this, go for exponent. Exponent symbol is denoted by double star. 2 star star 3 means 2 to the power of 3. How much? 8. This is about exponent operation. After that, we are going to perform the modulus operation, a modulus operator b. So here the result is 2. Why the result is 2? Why? Because we are dividing 2 with 3. Okay, 3 zeros are 0, the remainder is 2. So it is giving the remainder 2. This is about the arithmetic operators in Python. After completing this, next we are going for the relational operators. Now a equals to 2, right? B equals to 3. Now let us compare the variables a and b, or we can say the values of a and b, by using relational operators. See here, I am writing the first operation. A is less than b, less than operator. A value how much? 2. B value how much? 3. 2 is less than 3. Yes, the condition is true. That's why it is giving the result true. This is very, very important. Now, after giving the true, if I say b is greater than a, 3 is greater than 2, yes, the result is true. Now, can I say a is equals to b, a value 2 and b value 3? No, false. Here we have seen the less than operation, here we have seen greater than operation, and this is equals to. Just remember that whenever we apply the relational operators or comparison operators, the result is only the Boolean result. Means it may give true or false. If I say a not equals to b, then what is the result we are going to have? True. Why? Because 2 not equals to 3. Okay. Now, after this, you can use a is less than or equals to b also. A value 2, 2 is less than or equals to b. Yes, true. If I say another condition, a is greater than or equals to b, false. Why? Because 2 is greater than or equals to b, 3? No. So both conditions are false. So that's why the result is giving false. This is a simple discussion about the relational operations. Now go to the logical operators. But before applying the logical operators, what you have to do is first take the first expression as the relational expression. Second expression also you take as a relational expression. Then only you apply the logical operators. We said that there are 3 logical operators: and, or, not. Now we will see the logical operators. Let us take an expression like this. Here I am taking 1 is less than 2. This is one expression. Here I am using the relational operation less than. 1 is less than 2. And here I am using the operator and. After this, Here I am writing 2 is greater than 1. Let us see, the first expression is 1 is less than 2 and second one is 2 is greater than 1. Instead of using direct values, I can also use the variables, but before using the variables, we have to initialize the values. Okay. Now 1 is less than 2. Is the expression is true? Yes, the condition is true. Right. What is the Boolean result of 2 is greater than 1? Is it true? Yes. 1 is less than 2. This is true. And this is also true. At the time of discussing the logical operators, I said that when the two conditions are true, the result is true in AND operation. If any one of the two conditions is false, the result is false. This is very, very important. Only it gives true when both conditions are true. That is very, very important. Now, whenever I press enter, the result we are going to have true. For example, here I'm copying the same statement. Here I'm saying that instead of saying 1 is less than 2, just I'm saying 1 is greater than 2. In this case, what happened? The first condition becomes false. Second condition is true. So if any one of these two conditions is false, the result is false, as I said, false. For example, here I'm going to use second statement as less than. You see here. In this case, what happened? The first condition is true. Second one is false. In this case also the result is false. Okay. For example, here I'm writing 1 is greater than 2. Just I'm writing. This is false. 2 is less than 1. This is also false. I'm writing 2 is less than 1 and 1 is greater than 2. Both conditions are false. Here also the condition is false. When it gives true, when both conditions becomes true, then only the result of AND operator is true. In any other case, the result is false. This is about the AND operation. For example, I'm going to copy the same statement here. Just I'm going to paste this. Instead of using AND, I'm using the operation OR. In this case, what happened? The OR returns true if any one of the two conditions is true. If two conditions are false, then OR also gives false. This is very, if two are true, two conditions are true, the result is true. If the two conditions are false, the result is false. If any one of the condition is true, the result is true. This is very, very important. So in this case, what happened? 1 is less than 2. Yes, it is true. 2 is greater than 1. True. Both are true. In this case also the result gives true. For example, here what I'm going to do is 1 is less than 2. Okay. Here second I'm giving like this. 1 is less than 2. True. And here I'm going to use the operation OR. In this case, 1 is less than 2. True. 2 is less than 1. False. 1 is true and another one is false. So OR gives true here. If both are true also, the result is true here. If any one of the condition is true, the result is true. For example, I'm going to copy the same here. Control here, I'm writing. In this case, just assume that 1 is greater than 2 false, 2 is less than 1 false. Both are false. The result is false. Both are false, then OR gives false. If both are true, the result OR gives true. If any one is true, the result is true. This is about the OR operation. Now, what about the exclusive OR operation? Here, exclusive OR operation we are not going to perform. Exclusive OR is only available in bitwise operators. In logical operators, just we have three. First one is AND, second one is OR. Simple OR is there. There is no exclusive OR in logical operators. Now, the third one in logical operators is NOT. What do you mean by NOT? For example, I'm going to copy this statement here. Here I'm writing like this. Before this, I'm writing NOT. Okay, here I'm writing extra parenthesis. What do you mean by this? See, 1 is less than 1, sorry, 1 is greater than 2. No, this condition is false. 2 is less than 1, false. Both are false. When both conditions are false, OR gives false, right? The result within the parenthesis is false. Then not of false becomes true. Here the result we are going to get is true. Simply remember, not gives the negation. That means if I say 1 is less than 2 here, just I'm writing like this. I'm not using any extra expression, just I'm using only ordinary relational expression here. 1 is less than 2. So when 1 is less than 2, the relational operator gives true. Not of true, how much? No, it gives false. This is about the not operation. So with this, we have completed the logical operators. Now, next what I'm going to discuss here is, we are going to discuss about the bitwise operators. Let us discuss the bitwise operators. Now, I think in the theoretical class, we have taken some examples, right? Let us take the variable a is equals to 10. A value is 10. B is equals to 11. Now, here I'm using A and operation is bitwise and B. First, under bitwise operators, we are discussing bitwise and. So, I said that the input is given in the decimal notation or decimal number system. A equals to 10 decimal number, B is equals to 11 decimal number. Now, I'm going to perform the bitwise and operation on A and B, both are decimal. Input is in the form of decimal, but internally the operation is done at bit level. That means the value 10 is converted into binary and 11 is converted into binary, and at bit level we are going to perform AND operation. Okay, AND operation, what it is going to give? If two bits are 1, the result is 1. If any one of the bit is 1 other than see, two bits are 1, the result is 1. If two bits are 0 1, the result is 0. Okay, if any one of the bit is 0, the result is 0. If two bits are 1, the result is 1. If two bits are 0, the result is 0. It's same as the logical AND operation. Okay, now after performing the AND operation at bit level, the binary equivalent is converted into the decimal number, and finally we get the decimal equivalent. So the output we are going to get is 10. How the output we obtain 10? Already in the theoretical part I said 10 is converted into binary, 11 is converted into binary. At the binary level, we are going to perform this operation bitwise AND. Next, the resultant binary number is again converted into decimal. So that's why here we are taking 10. See, if I say, for example, same result, I'm going to get C is equals to A and B. Now, if I say C value, how much? 10. Already we have seen in theoretical part how we got this number, output 10, bitwise operation result. Similarly, you can perform not only A and B, you can perform ARB. ARB also you can perform here. So the result we are going to see here is, see here I'm writing, just I'm going to perform the operation ARB. The operation here we are going to get is ARB. This is ARB, bitwise operator. Now we can perform A exclusive OR operation. A exclusive OR operation also we can perform. See here, this is A exclusive OR. So we have completed bitwise AND, bitwise OR, bitwise exclusive OR. Next we have seen bitwise left shift. Okay, A value 10. This is bitwise left shift and bitwise right shift. We have seen this bitwise left shift, bitwise right shift, and also we have ones complement, bitwise not. I said that if A is equals to how much 10, right? Here I'm writing bitwise complement of A. 10 value how much? Minus 11. Already we have seen this. Okay. Now we have also seen that the ones complement of 11, we got 10. So ones complement of 10 is minus 11. Ones complement of minus 11 is 10. We also seen how to obtain the ones complement. So these are the simple bitwise operations. Okay, and the result is performed like this. The input is given in the form of decimal number system. The output we obtained is also in the decimal number system, but the operations internally done at bit level. This is about bitwise operators. Up to now, arithmetic operators completed, logical operators completed, and relational operators. Next, we are going to see assignment operators. For example, so A value already I said, A value what I said, 10, A plus equals to, for example, I'm writing 1. This is assignment operator. Or I can say first I'm going for simple assignment, assume that A equals to 12. A equals to 12, this is simple assignment statement. If I say A plus is equals to 10, for example, what's the meaning of A plus is equals to 10? Its meaning is a equals to a plus 10. That means we are going to obtain, whenever I say 12 plus 10, how much? 22. A value 12, 12 plus 10, how much? 22. That's why whenever I say a, it is giving 22. For example, a minus is equals to, a minus is equals to 1. Here I am writing like this. A minus equals to 1 means a is equals to a minus 1. See, what is the new value of a here? 22. 22 is equals to 22 minus 1, how much? 21. If I say a, 21. If I say a star is equals to 2, what's the meaning of this? A equals to a into 2. A value how much? 21. 21 into 2. The result we are going to get is this, 42. Okay, like this we can perform bitwise AND operations. For example, if I say a double left shift is equals to 2, what's the meaning of this? That means a is equals to a left shift 2. Now, whenever I say it is going to perform first left shift operation, the result is assigned to a and it is going to give the value of a as 168. So like this, you can perform right shift operation. Okay, now you say a is equal to 42. So left shift to right shift, we can also perform, what do you say, bitwise AND. If I say a AND equals to 2, what is that? A equals to a AND 2. That's the result. If you say 2. Not only this, you can also perform a operation AR is equals to 2. What is this? A equals to AR2. If I say A, the result we are getting. So like this, we can perform assignment operators on these variables. This is the introduction, or this is the hands-on experience on assignment operators. After this, we are going to see the membership operator and identity operators. Now, first we will see the membership operator in and not in. So first we will discuss in operator. Next we will see not in operators. These two are membership operators. Let us take the string s is equals to, here I am writing LearnNCode. This is the string. The string can be enclosed either in single quotes or double. Okay. Now I'm taking a string, substring, here I'm writing substring is equals to, here I can use single quotes or double quotes. Substring equals to how much? AND. Original string s is equals to LearnNCode. Now I want to check whether AND substring is the member of the original string s. That's what I want to check. If it is the member, or I can say a membership operator just checks the availability or the existence of one string in another string. The original string here we are considering is LearnNCode. In this string s LearnNCode, we are going to check the availability of AND. If it is available, then it is going to give the result true. If it is not available, it is going to give the false. That is about the in operation, or we can say in operator. Now, see here, I'm writing substring here. Okay, in. Yes, just I'm writing like this. You see here. Substring in S. Is it true? Yes. Opposite to this, we have not in. For example, here I'm writing substring. Just I'm writing not in. Just you write S. Not in. Okay, not in gives the result true when it is not there. The result of in gives true when it is available. Both are opposite. See, here assume that not in S, it is already there. For example, instead of using substring, you can also directly use a string in single quotes. Assume that I want to check. Here I'm going to check that, or I want to check or not in S, or not in S. So instead of using a variable substring like this, directly I can give my own substring in double quotes, and I want to check whether it is there in the S or not. You see here, true. Why? Or is not there in the string? Yes. So that's why it is giving true, right? Similarly, not only string, you can also take the list. For example, I'm taking the string, or taking the list here. Assume that the list 1, 2, 3, 4, 5, 6. This is the list I have taken. I want to check 1 in num. We say here true. For example, 2 in num. Yes, it is there. Okay. 3 is in num. You can take the result is true. For example, 9. Here I'm writing 9 in num. False. If I say 9 not in, for example, num, now it is giving the result true. So this is a simple. It says you can take the list, you can take the dictionary, you can take as a tuple. Okay, these are known as the sequence. If you want to check the availability, or we can say existence of some number, some value in any particular sequence, means it may be a string or it may be the list, tuple, or the dictionary. For example, here I'm writing just a dictionary. Dictionary is equals to, dictionary is declared by using opening brace. Here I'm writing the key value 1. Here I'm writing PSR, comma, 2 is another key value. Here I'm writing just string like this. Next 3, I'm using the string like this. So this is about the set, right? In this set means dictionary. In this dictionary, what I'm going to do is, I'm going to search the availability. So for example, assume that I want to search PSR. PSR. See, PSR is not the key value. Okay, it is the value of the key. Generally, in the dictionary, if you want to search any item, you have to search the item by using key, not its value. If you say PSR in dictionary, it will give error. PSR in dictionary, it will give error. Error in the sense, why it is giving the error? It is giving the result false. Even though it is available in the dictionary, it is giving the false. Why? Because it is not going to search the key value. Instead of giving key, if I say 1 in dictionary, 1 is there in the dictionary, 1 is the first key, right? If you give the like this, it is going to give true. So what I mean to say that, don't search the value of the key in the dictionary. You have to give direct key itself. So if you want to search PSR, just you give the key 1. If you want to search Sunil, you have to give the key value 2. If I say 2 in dictionary, it is going to give the result true. But if you take directly Sunil, it will give false. False means that is the error. Output is not correct. This is the way of searching or checking the availability or the existence of a particular value in a dictionary. This is about the membership operator. Okay. Now we are going to see the identity operator. What do you mean by the identity operator? For example, here I am writing x is equals to some value 10. X is 10. Now y is also I am giving the value 10. X is 10, y is 10. 10 means integer. Okay. 10 is common, right? X value 10, y value 10. When the value is same, in Python what happened? The memory for the variable y is not created. Only one memory location is created for the value 10 and it is labeled as x. Whenever we say y is equals to 10, separate object is not created, separate memory location is not created for y. Only one memory location is created with the value 10. For that, the label is x as well as the label is y. Labels are x and y, but the memory location is only 1. This is very, very important. Why? Because there is only one integer object. So when the memory is created, so each and every memory location is going to have some ID. This is very, very important. Some identification number. That identification number is given by the Python interpreter. So those values are unknown values. So directly they are assigned by the Python interpreter. Now how to get the ID of it? Whether we have separate IDs for x and y? No, we have only one ID. So how to get the ID? Just by using ID function. If I say ID of x, the value is this. This is some value which is given by the Python interpreter. If I say ID of y, we are getting the same number. You see here. Why? Because the object is same, the names are different. For example, if I say y is equals to 10.5, in this case, what happened? Now in this case, x is different and y is different. Why? Because X is 10, that is integer object, and Y 10.5, this is the floating point object. In this case, two objects are different and two memory locations are different, and both are going to have the different IDs. If I say ID of Y, in this case, we are going to get the different value. See here. If I say ID of X, we are getting the previous one. This is very, very important. Okay. Now, what are the identity operators is and is not? See, in the first case, both X and Y are going to have the same ID. Whenever we store the floating point value in Y, the ID of X and Y are different. See here, again, I'm going to use the same concept here. Assume that X is equals to 3 and Y is equals to 3, for example. In this case, what happened? Only one integer 3. How many labels are there? Two labels X and Y, both are having same IDs. Now, how to compare these IDs? If you want to compare the values of two variables, we can use relational operator. But if you want to compare the IDs of two objects or the variables, then you have to use ID operators. What are the identity operators? We have is and is not. Already we discussed. Now assume that here I am writing X is Y. In this case, I am applying the identity operator is. Now, what is going to do is it is going to compare the ID of X and ID of Y, or both are same, like I said in the previous example. Yes, same. How to get the ID of X? Just now I said you give ID of X. This is ID of X. If I say ID of Y, okay, both are same. That's why X is Y becomes true. If I say X is not, if both are different, then it is going to give false. See here, X is same and Y is same. So that's why is giving true. If you say is not, X is different and Y is different, no. That's why the result is false. Okay. For example, assume that just now we have given 3, right? Now I'm giving 3.5. Now both X and Y are different. In this case, X is not Y. Now it is giving the result true. Okay. So this is how we are going to use the concept of identity operators in Python. So with this, we had a practical, hands-on experience on these operators. With this, I'm going to close the session. Thank you for watching. We will see the next topic in the next session. Thank you for watching.